Hello AS Math, it is Mr. Knight back again with exercise 2C. This is the equation of lines, so a lot more review, but let's make sure we know these ideas and these concepts because one of our skills today is more of those dreaded shape application problems. So if we're not comfortable with this stuff, it's going to be hard to do those, okay? So some of the skills that we're going to go over today, other than dreaded shape application problems, is drawing a line given the equation, and then the opposite of that, which is actually finding the equation given these two parameters as well as given the graph. So you can look at the graph and be like, hey, I know exactly what the equation is of that line, and we'll talk about the features. And we have just two vocab words on the chopping block today. So without further ado, let's begin. General equation of a line. Well, we know that's y equals mx plus b. All reliable, okay? Where our m is our gradient or our slope, our rise over run, and then b is our y-intercept, okay? This is the key right here. This is what we're going to be referring to throughout this entire lesson, but we're also going to be talking about its less than stellar brother, let's call him, the standard form, okay? The standard form is px plus qy plus r equals 0, where p, q, and r are constants. I put gross by it because it is absolutely an atrocious abomination that has been bestowed upon us in the math world, and we unfortunately have to learn about it. I'm going to teach you how to work with it, but not necessarily use it that much, if that makes sense. Okay? Well, let's move forward. So, when we're talking about the equation of a line, there's a lot of different cases that can come about. So I created some graphs, and we're going to talk about some of these equation forms, okay? So we're actually, before we jump into these, we're going to actually take a trip to Desmos and see what's going on. So here we are at Desmos, and I'm going to show you those two first graphs, okay? So the first one is this guy right here. X equals 0 or x equals whatever, aka the equation of a vertical line. If I zoom out, I am never going to not see this thing be vertical, okay? So the form of that is x equals a or x equals whatever number you want to put out in front here, okay? And then likewise, we have the horizontal direction too. This is y equals whatever you got out in front there, okay? Right now I'm limited to negative 10 and 10, but you get the idea. This is the equation of a horizontal line, all right? So if we come back and we're looking at these two forms right here, so for example, I got x equals 3, so my vertical line is just going to go where x equals 3, so the x coordinate of 3, and then it's just going to go straight through there, okay, wherever it's at. If it was x equals 2, it'd be over here somewhere. Same thing with the horizontal lines. Okay, if I have y equals 2, that's going to cross the y-intercept of 2. And so this is vertical, and this is horizontal. Okay, it's important we know those lines. And of course, just by looking at them, if we just continued this horizontal line going across, they would be perpendicular. These lines are always, always perpendicular to each other. So then that brings us to our next batch, okay? So let's take this away for right now. Let's look at the y equals mx plus b. For right now, let's just imagine that b is 0. So we have no y-intercept we're going to deal with. So we're just going to deal with this guy. So right now our m equals 1, but I'm going to let it play, and you can just see what's going on. This slope is causing this guy to just kind of rotate about the origin right now. Notice as we're positive, we are going from bottom left to upper right, and that shows that our slope is indeed positive. As it climbs, it gets steeper and steeper and steeper, but it'll never hit the vertical form of the x equals. Okay. Likewise, if I'm going negative, it's going to be going from top left to bottom right, showing that this slope is declining over time, and it gets steeper as that value, the absolute value, grows. Okay. Now, if the slope is 0, you can see I basically have a horizontal line just like my y equals. Well, if I think about this, if I think if my m equals 0, right, then my mx term goes away and I'm left with y equals whatever b is. In this case, y equals 0, since b is 0, so I have the horizontal line going through 0. Up here, it's y equals 8.6, so they have slopes of 0, and that makes sense. But now let's go ahead and now let's see what happens if I have a slope of 1 and now I change my y-intercept. Well, this is what's going to happen. It's going to go up and it's going to go down. It kind of looks like it's sliding diagonally, but really what's going on is that my y-intercept, as this b term increases, it's going up. So my line has to cross through that y-intercept. So from that 3, I can expect 0, 3, my y-intercept be on my graph. And if I click, 0, 3 is right there. Okay? And that's really it. The m and the b, the slope and the y-intercept, that's pretty much what determines what your line is going to be behaving, how it will be behaving. So let's look at these two lines, or these two cases. Case C, y equals mx, where my y-intercept is 0. They're all going to cross through the origin, and I have negative 4x for this line, 1/2 x for this line. Okay? And again, you can see if it's negative slope, it's going from top left to bottom right. And then for y equals mx plus b, again, if I have my y-intercept as negative 1, I expect this line to cross through 0, negative 1. Same here, plus 1, 0, 1 right there. Okay? And now finally, the horrible atrocity known as standard form. Feast your eyes upon this one, okay? So here's an actual example of what you might see. You're probably not going to see it that much. If I have 2x plus 3y minus 6 equals 0, apparently that gives me a line that looks like that. Look, this guy and this guy are pretty much the same thing. They just look different. They're just different forms. So we're going to talk about how to work with this guy in this next example right here. Okay? Example 1, drawing a line given equations. Okay, so we're going to draw y equals x minus 1 and 3x plus 4y equals 24. Right off the bat, you see, I say, convert to y equals mx plus b. Do that right off the bat. How do we do that? Well, let's take a look. Let's bring 3x plus 4y equals 24 down here into the depths. And we want it to look like y equals mx plus b. So basically, y is getting isolated by itself. So if I can rearrange this guy to do that, it's going to look like y equals mx plus b. Let's do that. I'm going to move my 3x over. So I get 4y equals 24 minus 3x. And now I can just divide both sides by 4. So I get y equals, and I'm dividing both these terms by 4. So 24 divided by 4 is 6. And then 3 divided by 4 is 3/4. So minus 3/4 x. And if you want to rearrange this further, you could do y equals negative 3/4 x plus 6. And now it looks like y equals mx plus b. Okay? So that's how you do it. You get your y by itself, and it'll kind of work itself out to look like slope-intercept form. Now, let's actually graph these bad boys. So there's really two things we need when graphing. Okay? First one is the y-intercept. Right off the bat, let's label these y-intercepts. So for my first graph, my y equals x minus 1, I know 0, negative 1 is going to be one of the points, because that's the y-intercept. Cool. And then for this guy, I know that 6 is going to be my y-intercept. 0, 6. Okay, 1, 2, 3, 4, 5, 6. Sweet. And we're already halfway done. So we have the y-intercept. The second thing we need is the slope. And we have the slope for both of them. Okay? This guy right here, y equals x minus 1. Well, there's no m out in front, but there kind of is. It's kind of hidden. It's like a ghost. It's actually 1x minus 1. It's a slope of 1 over 1. So if I'm doing my slope, remember, that's the same as rise over run. So that's what you could do. You just start from your point. Let's start from, let's do this first one. And my slope is 1 over 1. So I'm going to go up 1 for my rise, and I'm going to go over 1 for my run. Up 1, over 1. Up 1, over 1. I'm going to keep doing that, and pretty soon, I have a pretty good idea what that line is going to look like, right? Similar here. I'm going to use a different color to kind of illustrate that. I'm going to use yellow. Yellow has not been getting a lot of love, guys. It's kind of hard to see. That's why. Hey, screw yellow. We're going to go brown. That's way better. All right. So now we're going to look at negative 3/4 x. That is our slope. So here's the thing about the negative, guys. It doesn't matter if the 3 is negative or the 4 is negative. They just both can't be negative, or else you'd have a positive fraction, right? So if you want to do negative 3 rise, you can do that. Or you could do negative 4 run and keep the 3 positive. It's up to you. So I'm going to do the top as negative. So I'm going to start here. I'm going to go down 3. 1, 2, 3. And my run is positive, so I go to the right. 1, 2, 3, 4. I'm right here. Once I get that second point, I know I put a lot right here, but once I get that second point, I'm done. That's my line. A line just needs 2 points, and that's it. Okay? We know where the rest of the points are going to lie. So this was y equals negative 3/4 x plus 6, or that horrible abomination which we just changed up. Okay? I hate standard form. I don't hate a lot of things in life, but standard form is one of them. Okay? So, now let's look at the second skill. Okay? This is finding the equation of a line given, and we have 3 things. There's a graph, slope and point, and then 2 points. So let's look at this first case. Let's say I'm just given the slope and 1 point. Right? So if I'm looking at this guy, it says find the equation of a line given a slope of 3, so m equals 3. Or you can write it as 3/1, kind of give your, help you with the rise over run. And then we know the point is 2, negative 4. I don't know what the y-intercept is yet. So if I'm trying to make this equation of the line, right? Well, I know what my m is. Y equals 3x plus b. But I don't know what b is. How can I find it? Well, there's a reason I said it was point xy. Hey, I can plug those in for x and y, and then just solve for b. And there you go. I have one variable. Let's do that. So I'm going to replace y with negative 4, my x with 2, and then we're just going to do some math. Okay? So I got negative 4 equals 6 plus b. Subtract 6 over, b is going to equal negative 10. So my final answer, my equation, is y equals 3x minus 10. And there you go. Nothing to it. Okay? Put your slope in, and then put your points in, and then find b. Okay? Now let's say you're not given the slope. Let's say instead you're given 2 points, 2 pairs. I'm going to call this x1, y1, and x2, y2, right off the bat. Well, I don't know what my slope is, but I do know how to calculate it. Okay? y2 minus y1 over x2 minus x1. I know I can do that, so I'm going to replace these. 3 minus 4 on top, 5 minus 2 on the bottom, and I get negative 1 over 3. Okay? So negative 1/3 is my slope. So my equation so far is this right here. And look, we're back to square one right here. All I got to do again is plug in an x and y. Which one? It does not matter. Okay? We're gonna pick 2 and 4. 4 equals negative 1/3 times 2 plus b. We'll write it up here. We get 4 equals negative 2/3 plus b. I add the 2/3 over, so this is 12/3 plus 2/3, which equals 14/3. So that's my b right there. So my final form for my equation is y equals negative 1/3 x plus 14/3. Okay? Both cases work. All right? This one might be a little bit more involved. Unless they give you the y-intercept from the get-go, you're going to have to find your slope first, and then you're going to have to plug the points in. Okay? And now for C, the last one, the last case. What if I give you the graph, and we want to find the equations of the line A through C? Well, we've kind of already seen how you can be given the equation and then graph it, but now we're going to graph it and find the equation. Again, we need two things. Remember, we need our y-intercept, and then we need our slope. And we'll have everything we need. So if I'm looking at A, this A line, well, it looks like 0, 2. 2 is my y-intercept, right? And then let's see, using the slope of rise over run, so I'm going to say use rise over run. Okay? This thing is going up, looks like it's going up by 1 and over 1. So 1 over 1, m equals 1. So my equation is y equals m, which is 1, so 1x plus 2. And there we go. You can even plug in an additional point to see if it works. So if I plug in -2 in for x here, I should get 0 for my y. -2 plus 2 is 0. That works out. Let's look at the second one, letter B. Well, this looks like a horizontal line. So I know a horizontal line right off the bat. That's y equals whatever the y-intercept is, which is 4. Done. If it was vertical, it'd be x equals whatever that x-coordinate is that it's lying on. Okay. And then for C, finally, looks like my y-intercept is 0, so I'm just going to have y equals x. I'm going to have some kind of slope. Well, let's see what my slope is doing. It looks like it's going down 2 over 1. So -2 over 1. So that would be -2 for my slope, -2x. And there we go. Those are the equations of those lines. Okay. So those are really the basic skills that you're going to be needing to be successful. Okay. And we're almost done. Here's some shape applications. There's 2 definitions we needed to hit on earlier. Okay. So this first one is a bisector. Okay. So it might ask you, find the equation of the perpendicular bisector. And you're like, I don't know what that is. Okay. A bisector is just a line that cuts something in 2 parts. So if I have my line right here, I can bisect it with a different line, and it's going to cut both of these in half. Okay, hopefully not my arm getting chopped in half, but you get the idea. And so this right arm that I'm using, this would be my perpendicular bisector. Okay, it travels through the midpoint. That's very, very important to know. Okay, so if this black line is a line I have, and my bisector is going through, this is going to be at my midpoint. Okay. At midpoint. Or you can do at midpoint. You can do like a Twitter handle, at midpoint. It's actually a pretty sick Twitter handle. I'm going to steal it. Just call me midpoint. That's actually kind of lame. Never mind. Alright, and then the second definition, median. Okay, so a median. This is concerning more of triangles. And really, it's just a line from the vertex. Okay, so the vertex here, or here, or here, through the middle of the triangle. So I'm going from this vertex, and I'm going through the middle. And there's always, always, always 3 medians that go through a triangle. Okay? Because that's, well, 3 vertices. And this is called the centroid. That's not very important, but I thought you'd like to know. And this does not act the same way as a bisector. It's not going to make this perpendicular. It will not. Okay? So I just wanted to make that clear too. Now here's our example. Here's our application. Find the equation of the perpendicular bisector of the line joining P -4, 5 and Q 2, 3. Alright, let's do that. Okay. So again, I'm going to draw a picture just because I like drawing pictures and I think they help. And I really want to see what this line is doing, this bisector, kind of get a better idea about it. Alright, so -4, 5, -4, and then 1, 2, 3, 4, 5. That's point P. And then Q is 2, 3. Okay, and there's a line connecting them. I'm just going to replace that because we don't need it anymore. and this line is going through here. Now, with this line, there's the perpendicular bisector, okay? So the perpendicular bisector is going to act somewhere like this, okay? Something like this, right? It's going to split this line in half. Okay, I don't know if it's through that point. I don't know if that's the midpoint. I'm just kind of getting an idea of what this is going to look like, okay? So the first thing we got to do, if we want to find the equation of this line, right, there's two things we need, right? Again, we need the y-intercept, and we need the slope. Well, it's a perpendicular bisector. It's perpendicular to this line. If I know the slope of this line, I will know the slope of the perpendicular bisector, and that'll help me, okay? So let's see. Let's see what we can do. I know that the equation of this line between 2 points, well, I don't need the whole equation, I just need the slope. I know the slope of PQ is going to be, I'm going to call this my x2, y2, is going to be 3 minus 5 over 2 minus 4, so plus 4. So I get negative 2 on top, I get 6 right here, and I get negative 1/3. So now my slope of my perpendicular bisector, my slope of perp skirt, is going to be, well, opposite reciprocal. So 3 over 1, so just 3. And that's pretty useful. Now, I have the slope. Now, to find the y-intercept, well, I'm going to need, if I'm doing the equation of this, I needed an x and y coordinate still, right? I don't have an x and y coordinate. But I do know, based off my definition of a bisector, that it's going to travel through my midpoint, right? So I can find the midpoint of this, and that'll be my x and y that I can throw into here, okay? Let's do that. So let's say that, I'm having a brain fart right now. Does anybody ever have that happen? It just happens randomly? Okay, midpoint formula. I know that's going to be x1 plus x2. Okay, so it's going to be negative 4 plus 2 over 2. And then my y coordinate is going to be 3 plus 5 over 2. Negative 4 plus 2, negative 2 over 2 is negative 1. And then this is going to be 8 over 2, which is 4. So that is my x and my y that I can actually plug into here and here. Okay? Well, let's do that. So I get 4 equals 3 times negative 1 plus b. 4 equals negative 3 plus b, so b equals 7. So that means that my equation of my perpendicular bisector is y equals 3x plus 7. And there it is. Okay? Now for your homework, you guys have one application problem for sure. And I'm going to touch on it briefly and kind of give you an idea of what you need to do for it. So number 5 is one of your problems, and this is the application problem. It says triangle ABC has an angle of 90 degrees at B. Point A is on the y-axis, AB is part of the line x minus 2y plus 8 equals 0, and C is the 0.62. It throws a crap ton of information at you. So my first thing I would tell you to do is draw a picture, if possible. Try to sketch this as much as possible. And in fact, you're going to have to anyway, right? Part 1 asks you to sketch the triangle. Okay? Well, you've got to kind of figure out where those points are, right? It only gives us point C. So point A and B are kind of on our own a little bit. So to kind of help you get going on it, we know that point A is on the y-axis, right? So because point A is on the y-axis, we know it's going to have coordinates 0, y, right? 0, y. The x coordinate is going to be 0. We know that because it's on the y-intercept, or on the y-axis, okay? So point A will have 0, whatever that y coordinate is. So that's actually useful. And we know that AB is on this line in gross standard form, but we can actually use the standard form in this case. Because I know point A is going to have an x coordinate of 0, I'm going to plug 0 in for x. And now I can just focus on solving for y. I can get my y, and then I can get my point A from there, get my xy. All right? And you know A, B are both on that line, so if you have this rearranged to y equals mx plus b, you can use that slope, you can use that equation of the line to help you figure out where point B is actually going to lie. Okay? And then when you find the points, then it's all about finding the equations of AC and BC. Okay? Again, this angle of 90 degrees, that's probably going to come in handy because it's telling you it's perpendicular. So use that for one of your slopes. Use that idea, okay? And then when you find the lengths of AB and BC, you can do that with the distance formula and find the area with base times height divided by 2. Okay? Good luck on your homework. Let me know if you have trouble on this problem. Shoot me a message, and I will give you more tips on how to do it, but I want you to try it on your own. This is Mr. Knight, signing out.